All right, so I want to talk about ln of x and what to do and what not to do. So like in this example here, you have x and times ln of x. So I want to give you a rule that you never want to move ln of x to the denominator. Never move ln of x to the denominator. This one here, I can put x in the denominator as 1 over x. And then doing L'Hopital's, I get 1 over x, negative 1 over x squared, right, derivative. Flip this, multiply by the reciprocal, cancel. Look at that, it equals 0. So let me just show you what would happen if you did move ln of x to the denominator. All right, so if I take the derivative, so this is putting in 0, so I get 0. So if I put 0 in, ln of 0 is infinity, 1 over infinity is 0, so it is 0 over 0, L'Hopital ready. So take the derivative is 1. Oh, how do you take the derivative of 1 over ln of x? So that you would really need to think of as ln of x to the negative 1. So let me write my limit here. So I'd have 1 over, and I'd bring negative down, ln of x to the negative 2 times 1 over x. Do you see that this is a bit more challenging? Yes. So I'm going to encourage you never to move ln of x to the denominator and just move the other guy to the denominator. Here's another one. Tangent of x, ln of x. So if I put in 0, I get tangent of 0 is 0, ln of 0 is infinity, so it is 0 times infinity. Move the trig function to the denominator. To move tangent to the denominator is cotangent. So much easier to take the derivative of. So derivative of ln is just 1 over x. Derivative of cotangent, you know, is negative cosecant squared. So you have a fraction, and I see 1 over cosecant squared as a fraction. It's 1 over sine squared. So let's multiply by reciprocals, and I get to here. I get 0 over 0. Okay, do L'Hopital's one more time. So you do chain rule, bring the negative 2 down, sine of x to the 1 power, derivative of sine is cosine, the derivative of x is 1. Now plug in 0. I get 0 times negative 2 times 1. That gives me a 0 in the numerator over a 1. 0 over 1 is 0. All right, so that's just a little tangent there, a little aside about ln of x. Okay, so let's talk about another more work category that I've got, which is infinity minus infinity, yet another indeterminate form. So what we need to do is we need to make common denominators so that we can get it to L'Hopital's. And remember, in order to use L'Hopital's, it has to be 0 over 0 or infinity over infinity. So you can't use subtraction. So I can see that if I plug in 2, I do get 2 over 0 minus 8 over 0 minus 2 over 0. So it is infinity minus infinity. So let's make common denominators, and I see the difference of squares. So let's multiply this one top and bottom by x plus 2. You have to make one fraction before you go do L'Hopital's. So let's put it together. So I'd get 8 minus this, right, over this. And I'm just going to multiply this out so it'll be easier for me to take the derivative. So I get negative x squared minus 2x. So now I'm ready to do L'Hopital's. So if I take the derivative, negative 2x minus 2, derivative of x squared 2x. Now what happens when I plug in 2? If I plug in 2, I get negative 4 minus 2 is a negative 6. Put in a 2, I get a 4. There it is. So negative 3/2 if I wanted to simplify it. Here's another one. If I put in 1, ln of 1 is 0. And that gives me a 3 over 0. Put in 1, I get 2 over 0. So you get 3 over 0 minus 2 over 0. So that's infinity minus infinity. Okay, so let's make common denominators. Multiply this one top and bottom by x minus 1. Multiply this one top and bottom by ln of x. Put them together into one fraction. And I'm going to even, did I multiply it? Yeah, I guess I just didn't multiply it out. So I didn't see it was going to be that hard on the top. So I put them together into one fraction. And so now I'm going to do the L'Hopital's. The derivative of this, derivative of 3x minus 3 will just be 3. Carry the negative 2. The derivative of ln of x is 1 over x. Now take the derivative of the denominator, you see it. It's product rule. First d second plus ln of x times the derivative of this, which is 1. So then I'm going to plug in x equal 1. So I guess I didn't finish it. So let me finish it off here. So I get 3 minus, I'm putting in 1, so I get 3 minus, I guess I don't need the limit anymore. Sorry about that. I'm plugging in x equal 1. I get 3 minus 2. Plug in x equal 1. This gives me 0, right? So that's all gone. And ln of 1 is 0. What? I get 1 over 0. That's where it is. That's where I got dne. So a number over 0 is not undefined. We say does not exist.